Hello, everyone. This is part three. I'm still talking about the effective length factor. So let's solve a problem on it. The problem statement reads, a rigid unbraced momentum frame is shown in this figure here. Determine, let me grab my laser point, determine the effective length factor with respect to the weak axis for member A, B, and B, C. So determine the effective length factor. They're talking here about K value. They want you to find K value for column A, B, and B, C. This is a building with 2 stories that consists of girders and 3 columns, for instance, simply, right? So then the way we go by this is finding G. We have to find G at each point in order to find K value for each column. So let's start with joint A. Now we learned that from previous lectures, at joint, a fixed end joint, G is always 1. So then we have 1. So the way first we go by 3 steps to solve this problem. The first step is to break down the building into columns and girders. So joint A is fixed from here, and your G is 1. No question about it. Let's move on to point B. Point B consists of columns and girders. So at point B, we have 2 columns, W10 by 33 and W10 by 26. And also we have 2 girders, W14 by 24 and W14 by 26. So let's work first on the 2 columns, and then we'll work on the girder. That's why we have columns and girder solutions. So for joint B, we have W10 by 33, W10 by 26. First, we need to find the moment of inertia. How do we find the moment of inertia value? If you go to your textbook, go to the appendices, go to page 442. Table C.1b should show you the value of the moment of inertia. So now you will need to find the W10 by 33. So the first column, you can find the W10 by 33, and then to the 4th column to the left, your moment of inertia is 171. Your length here, it's already given, which is 15. And then by dividing the 171 over 15, it gives you 11.40. The same thing you do with the W10 by 26 from the same page of the appendix. You'll find the value of I, and the 12 is given to you for this column B and C. Then you divide the 144 over 12, and you should have 12. Then those are for the columns. Now let's work on the girders. We have 2 girders, W14 by 22, W14 by 26, which are here. The same thing, you find the 14, W14 by 22 and W14 by 26. You should go to one page before. It's either it's from page 440 or 441. You should find I, the moment of inertia for these 2, and then by dividing them by the length, because their length is from here to here and from here to here is 20 feet, that's your value. So then we find the 2 columns values, then we add them up, the I divided by L, I divided by L, then we add them up. The same thing for here. And then we divide the column summation by the girder summation. If you remember the equation of G, right, the summation of the column over the length over the girder, that's what we did here to find G. So now we found G 1.05 for joint B. The same thing goes for C. For C here, we have one column and two girders. So we come here for joint C. We have 10, W10 by 26, which is this column here. And the same thing you do, you go to the appendix, you find I, you divide it by 12, the length, then your I over L is a 12. Now, because we have at the same joint, we have two girders. One girder moment of inertia is this, 88.6 divided by 12. It gives you 4.43. The same thing for here. Then you add them up. Then you divide the 12 by this value. It gives you 135. Now, from this process, we found G value at joint A, joint B, and joint C. Why did we have to find this again? To use the alignment charts so we can find K value for each column. So then we go to the second step here, and let me grab my pen. So your first value, GA, is 1, and your GB is 1.05. Your K is 1.3. How did we find this? Just remember the two values. GA is 1 and GB is 1.05. If we go back to our column here, what do we have here? We have, well, let me, so it's unbraced moment. That means it's a free swaying. So then what do we have? We have 1, not to prevent it, right? So then we have GA is 1 and GB is 1.5, because this moves in portions 1, 2. So 1.05, I would assume it's here, and 1 is here. If I connect this point to this point, it should be here, and it's this goes 1.1.1, so it's 1.1, 1.2, 1.3. So this is 1.3. If I go back to K value is 1.3. Then the same thing applies. So the 1.3 for this column here, 1.3. Now we want to find the K for this column. Remember the two values again. Now we're going to assume that 1.05 is GA and 1.35 is GB. See here, because we took the two joints, this one was 1, this one was 1.05. Now if we go into work on this one, then this joint is 1.05, this joint is 1.35. And if I go back, it's 1.05, so I'm just gonna say it's something like here, and 1.35. If here in the middle is 1.5, then I think 1.35 it should be here. Then if I connect this with this, if this is 1.3, then this should be 1.38. It's something like close, right? Then it gives me K for this column is 1.38. And by this, we found the K value, the effective length factor for this column and this column.